Hi, my name is Muhammad Ibrahim Sheikh, and I am a graduate student of New Mexico State University, and I am pursuing my Masters of Engineering in Civil Engineering. Today, I am gonna do a assignment, which assignment is of payment analysis and design. This is our 11th chapter, and we got assignment from our professor to do video based work that we are doing in Excel and also our manual designing that we have done in a Word form. I'm going to explain this in both the manual things and also the Excel sheet also. So we got a question from our textbook that is 11.9. A question is gonna be a a 12-inch full depth asphalt pavement is placed on a subgrade with an effective roadbed resilient modulus of 10,000 psi, assuming a layer coefficient of 0.44 for the hot mix asphalt. A drop of psi from 4.2 to 2.5 and overall standard deviation of zero point 0.5 and a predicted asphalt of 3 into 10 power 7. So here we need to determine the reliability of the design by the ASTO equation and check the result by the ASTO design chart. So let's do first. I have done a manual designing over here. First, I will explain this one to you. Using an equation of asphalt equation, we have a log W base T12 is equals to, we have equation over here, and the design data are 3 into 10 and P base T 2.5 and SO, MR, SN will we need to find, and A1 is also given is equals to 2 point, A1 is equals to 0.44. Using a equation 11.2 asphalt equation, as we have given instructions from our professor, we have to use this asphalt equation. So using equation of Sn is equals to A1 D1 plus A2 D2 plus AT D3. So D2 and D3 are equal to 0 here. So Sn is equals to 0.44 into 12 is gonna be 5.82. So now we got an SN over here around 5.28. So while we go to the Excel sheet over here, I'm putting an equation. Yeah, this Excel sheet I have already created with formulas. So W18 is gonna be 3,000 and SO it's gonna be 0.5, and we got SN and I'm applying 5.28 over here, and PT is 2.5, and MR is gonna be 1000, and A1 is given in the question is 0.44, and D1 is gonna be 12. So by applying in a formula, we are getting this value as minus. We are supposed to get a value which is equal to the, now you got over here. We got a value manual calculations as minus 1.64 from the table of 11.15 we have in our textbook, that is 90% of the reliability ZR is equals to minus 1.282, and if we get the difference as it's mentioned over here in the question itself is that we need to get the answer in 88%. So interpolating is 90% to 85%. We need the mid from this both. So it's gonna be ZR 1 minus 1.282, and 85% it's gonna be 1 minus 1.037. So by interpolating these values, we got this plus by dividing all these 87.6 something. So it's gonna be 88%. So from table 1.5, it's gonna be 88% reliability. So we got here some variation in the value. In the value is we got minus 1.4, but the value is supposed to be around minus 1.2, so it's gonna be around 88 to 82%. So in this way we have substitute our values over here, the given data from the question, and we have a formula also over here. So this formula help us, as I can see over here, I am explaining you log on the brackets of C3 minus 9.36 log C6 plus 1 we have substituted in this value, so we got minus 1.40. So this is quite variation from the value, but we got around the same, almost the same from 1.17. So as I can see over here, manual calculation I have done from my textbook, and the calculations by my hand in a notebook, and I put it in the word form. So we got some variation in the value, it's 1.4. So answer should be 88%. Thank you for uh, listening me, and this was part of my assignment and I have done my part. Thank you very much.